Okay, in this video, we will solve this problem right here. And in the description box of this video, there are two playlists. One playlist has categorized limit problems, and the other playlist has random uncategorized problems. And so let's begin. Now with this problem, it says x is approaching infinity. If you plug an infinity here and an infinity here, you would get infinity over infinity. And so that's a red flag that you have to approach this problem differently. And because we do in fact get infinity over infinity, we can use L'Hopital's rule. So let's use L'Hopital's rule. So we're going to get the limit as x approaches infinity. And with L'Hopital's rule, we're going to take the derivative of the numerator and take the derivative of the denominator. And the derivative of 3 times x would be 3. Now this piece right here, we'd have to use a chain rule. The derivative of ln, you would get 1 over the inside piece, so 2 plus 4e raised to x. Then you would need to take the derivative of the inside piece. The derivative of 2 is 0, and the derivative of 4e raised to x would give us 4e raised to x. So let's write this down, 4e raised to x, like that. And we can do a parentheses. And so let's kind of rewrite this a little bit so it's kind of nicely aligned. So we have the limit as x approaches infinity. Now with the 3, because this piece is a fraction, why not make this also a fraction? So instead of saying 3, you can say 3 divided by 1. This will allow us to have a fraction over a fraction. And then we'll do this piece right here. So we have 1 times 4e raised to x, so we're going to get 4e raised to x, divided by, we have 2 plus 4e raised to x, close parentheses. So now let's clean this up. We have the limit as x approaches infinity. Because we are a fraction over a fraction, we can just do a rearrangement. And so we'll get 3 divided by 1 times 2 plus 4e raised to x divided by 4e raised to x, like this. Okay, again, we can kind of simplify it a bit. So we have the limit as x approaches infinity. And 3 times 2 would give us 6. 3 times 4 would give us 12e raised to x divided by, we have 4e raised to x. And now we can plug in infinity. We would get infinity over infinity. So again, we can use L'Hopital's rule for a second time. So we're going to use L'Hopital's rule one more time. We have the limit as x approaches infinity. We will take the derivative of the top and the derivative of the bottom. And the derivative of 6 is 0. Derivative of 12e raised to 6 would give us 12e raised to 6. The derivative of 4e raised to x would give us 4e raised to x, close parentheses. And then we can simplify it again. The e raised to x would cancel. 12 divided by 4 is 3. And so our final answer would be 3. And that's all we need to do for this problem.